6, 7.
6, 7.
All right.
7. Woo!
You done? I don't have to go over this. I can just let you be responsible for this information and give you your quiz tomorrow. Like an actual college class. All right, so define or give an example of the following. Matter would be?
You gotta put it down.
You can't see it? All right, so matter is anything with mass and volume.
Which one's that the answer to?
Matter.
Oh.
The first one. An atom. An atom is the smallest part of an element that retains the properties of that element. Now notice you can also just give an example, which might be easier for some of these.
On the test, is this going to be one of the ones where you like have the letters and then you have...
When you get the test tomorrow, you'll find out.
Ooh.
So, an example of an atom, hydrogen would be an atom, right? Or anything on the periodic table that has its own symbol, any of those are atoms. Then a molecule. An example of a molecule, if you were going to do the example thing, H2O is a molecule. And it's kind of one of the focuses of this particular quiz. But definition is two or more different elements that are chemically, it's okay, I'll just send it to your parents
Yay.
Yay!
and the principal.
Oh, don't do that.
Alright.
Where's the recording device at?
So, two or more different elements that are chemically combined. Specifically, if it's a molecule, they are covalently bonded. So, a compound fits this definition also, but molecules, to be very specific, they're covalently bonded. Whereas something like salt is not covalently bonded, so it's not considered a molecule, it's just a compound. All right, so next, proton. The proton is a subatomic particle located in the where? In the nucleus, and has a positive charge. The number of protons is the identity. You left yours on the back table, Dash. It's still, it's probably still there.
Yeah, I'll go inspect it.
Yeah, because it was important to you, so you left it there. So the number of protons is the identity of an element. So any element with 6 protons, for example, would be carbon. A neutron is a neutral subatomic particle. Can we still see this? Maybe scoot it up a little bit. Neutral subatomic particle, also in the nucleus, and the electron is a very small subatomic particle located in the electron cloud. And even though they're small, electrons determine how different elements will react with each other, how they'll behave, what their characteristics are, whether they need to gain or lose electrons, whether they'll form covalent bonds or ionic bonds or both, is determined by electrons. Then an isotope is simply a version of an element with a different number of neutrons. For example, carbon, most of the carbon out there is carbon-12. So this would be its mass number, this would be its atomic number, the number of protons, and that makes it carbon. But some carbon is carbon-14. The carbon used is the radioactive isotope that we use in radioisotopic dating of things that were once living. So these two things are isotopes of carbon. There's even some, very little, but there's some carbon-13 out there. These three isotopes of carbon are all different versions of the same atom with different numbers of neutrons. So this carbon has 6 neutrons, this carbon has 8 neutrons, and this carbon has 7 neutrons. But they all have 6 protons, that's what makes them carbon.
You're gonna be gone tomorrow, right?
I'm going to be gone tomorrow, that's why I'm recording this. And it's also recording it so that because there's between soccer and volleyball, there's and a concert and somebody else is sick or something, there's like 11 kids gone, so hopefully they can catch up and find it. What? All right, so what elements make up most of the mass of living things? Yeah, most of the mass of living things is made up of carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. On the next quiz, you'll need to know, for example, carbohydrates and fats contain carbon, hydrogen, and oxygen. Nucleic acids contain carbon, hydrogen, nitrogen, oxygen, and phosphorus. Proteins contain carbon, hydrogen, nitrogen, oxygen, and sulfur, but no phosphorus. Those sorts of things. But that's next chapter, chapter 3. So the difference between ionic and covalent bonding. Ionic is where electrons are transferred. This was one of your entry tasks, by the way, the other day. And covalent is where electrons are shared. Then be careful, just like some of you on your first quiz, you didn't answer the entire question, so you lost points. There's really 2 questions here. So you did the first one, the difference between ionic and covalent bonding, then what type of bonding occurs in most biomolecules. Most biomolecules are what type of bonding?
Covalent.
Yep. Most biomolecules are covalently bonded. Then, if you wanted to, as far as differences between ionic and covalent as well, you could say that ionic bonds happen between metals and nonmetals, whereas covalent bonds happen between nonmetals. And carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur are all nonmetals. That's how you know that living things form covalent bonds. So then the reaction for photosynthesis or the reaction for cellular respiration, label the products and the reactants. So which one do you want to do? Hint, they're the same reaction, just depends on which order you write them in. All right, so photosynthesis is CO2 plus H2O, making C6H12O6 plus O2. So plants take in water and carbon dioxide, they make sugar and oxygen.
Do you also need to label energy in there?
You could say that you need light of a certain wavelength. It also requires a pigment molecule. Do we know the name of that? Chlorophyll.
Well, that's the green stuff that's in the...
Yeah, it's a pigment. It's what you give a hog with bad breath. A pigment. Alright, so,
We need to know this.
is this balanced?
No,
No. Does it say you have to write a balanced equation?
no.
No, but could you balance it?
Extra credit.
Extra credit? Probably not. But you could balance it pretty easy. There's 6 carbon on this side, there's only 1 on this side, so put a 6 there. There's 12 hydrogen on this side, but only 2 on this side, so put a 6 here. And then that makes a grand total on
Really?
this side of 6 oxygen plus 2 more oxygen, but over here you've got 12 plus 6 is 18 oxygen. So to get 18 total oxygen, you need a 6 in front of that one. 6 times 2 is 12, plus 6 more, and then it's balanced. Now, if you drew the arrow going the opposite direction, what would you have?
Cellular respiration.
Not photosynthesis, but cellular respiration. So when it's going this way, it's cellular respiration. And when it's going this way, it's photosynthesis. For a product of cellular respiration, over on this side, makes water, carbon dioxide, and ATP, which is the cellular energy currency, if you will. It's a high energy molecule that your body will learn a lot more about later. What does what say? Photosynthesis? Cellular respiration? Which part? You got it? All right. Can I turn the page like Bob Seger?
Well, we have to know this.
Oh, label the products and reactants. All right. So if it's typically we write the reactants on the left side. So the reactants for photosynthesis are carbon dioxide and water, and the products. Thanks for the catch, Leah. And these are the products. I didn't answer the whole question. I would have missed some points because I didn't label it. All right, so products, reactants. Now, of course, if you wrote it going the other direction, then essentially the products of cellular respiration are the reactants of photosynthesis and vice versa. Yeah? Now can I move it? See. Chameleon lying there in the sun. All right, next. Oh yeah, I'm recording. Yeah, you get to hear me sing. All right, so sketch 2 water molecules. So here's one water molecule.
6 or 7.
It's so not funny. So 2 water molecules. Check. We did that part. Sketch 2 water molecules. Explain why water molecules are polar. So, water is polar because why? Because there are unshared electrons that are not distributed, you could say, equally. In other words, the oxygen is highly electronegative. Oxygen has 6 protons, 6 positive charges, attracting those negative electrons. The hydrogens only have 1 proton to attract those electrons. So that makes the area around the oxygen much, much more negative than the area around the hydrogen. Essentially, the hydrogen doesn't have those electrons, but it kind of does. Show the hydrogen bond between the water molecules that you drew. So the part near the oxygen is negative, the part near the hydrogens is positively charged, relatively. So the attraction between water molecules, not within water molecules, but between water molecules, between the positive part of this one and the negative part of that one, this is the hydrogen bond.
I bet you could make a Santa Claus joke with water molecules because it's great. It's like ho ho ho. So you could make
Oh yeah, that is a good
like
joke.
those funny jokes that you put on your PowerPoints and
Yeah.
things.
Yeah, cause like.
All right, so let's move on. So we've done all of 5. Why water molecules are polar, show the hydrogen bond between the water molecules that you drew. Number 6, and this is worth this is the big money question for this quiz, right? This is where you are gonna have most of your points. So 5 properties of water that make life as we know it possible. For each property you list, discuss how or why that property is essential for living things. So, what's property number 1 that you want to go with?
Adhesion.
Adhesion. Okay. Adhesion. And the rest of the question, so it's list, then it's for each property you list, discuss how/why that property is essential for living things. So how is adhesion essential for living organisms? Okay, so adhesion allows water to be transported to the leaves of what we call vascular plants. And those vascular plants can be like 100 meters tall. Maybe not quite that, but a lot. They can be very, very tall. And yet, because there's a pressure difference between the water that's evaporating out of the leaves at the top and the water that's being taken in by the roots, that water then through adhesion and cohesion can be drawn all the way up to the top of the tallest plants.
Vascular? Yeah.
Yes, vascular. But another important part of adhesion is it causes water to stick to surfaces and adhere to surfaces so that things stay wet when you water them.
Is water wet?
Yes.
What makes water wet?
Let's move on. So what's another property of water?
Cohesion.
Cohesion. All right, we can do cohesion. And why is cohesion important?
Because it allows water to work with itself.
But why is it important to living things that water is attracted to itself?
Because when you drop water, it kind of stays together and it's easy to clean up.
Okay.
It's essential for my life.
Yeah, it allows water to flow and form droplets and to travel. That's kind of related to the adhesion cohesion work together to allow water to travel through plants, but also to allow water to travel through you. What's another one?
Low density when frozen.
Low density when frozen. Can I just put expands when freezing? Same thing. But low density when frozen. Expands when frozen. So if something takes up more volume but has less mass, but has the same mass, then its density goes down, and so it'll float. So it expands when it's frozen. This allows ice to form on top of water, water bodies like lakes, streams, rivers, and even oceans, and then that insulates the water underneath, leaving a liquid layer that aquatic organisms can live in even when it's cold out. So that's important. Allows ice to form on top of water bodies so that lakes, etc., do not freeze solid. Unless they're really, really shallow, then they might, if the soil is also really cold underneath. But things don't freeze solid, that allows organisms to live underneath them. But also, expanding when it's freezing also leads to what we call frost wedging. Which is where when water gets into cracks in rocks and then it freezes and it breaks rocks down, and frost wedging that leads to eventually it helps with soil formation from bare rock. It also, if you remember the pica unit, if you were in my class, it allows for the formation of talus slopes, which are essential for pica habitat. It breaks rocks into smaller rocks, and eventually those smaller rocks get combined with organic material that gets broken down and soil forms. Depending on the climate, it can take 100 years for just an inch of soil to form, or longer.
About 6 or 7 years.
All right, so that's 4. What's another, or 3? What's another one?
Ooh, that's a good one.
Yep, high heat capacity. So it takes a lot of energy to heat water up. It also takes a lot of energy to cool water down. So water can act as a heat sink, is what we call it, to do things like mitigate or modify climates. So places that are near the ocean, near a large body of water, tend to have a milder climate because that water is affecting the amount of heat that is absorbed and released during the day. But also the high heat capacity means that it can help to regulate body temperature in critters like us that sweat. So when you sweat, it takes a lot of energy away from you to cool you down to evaporate that water. So it also helps to regulate your body temperature in organisms that sweat and need to regulate their body temperature. So, but the main thing with a high heat capacity is water absorbs and then stores a lot of energy. And so temperatures worldwide would be a lot different and have a lot more fluctuation if we didn't have so much water on the planet. Bailey.
That word after the
Mitigate or modify climates, right? So the reason that Seattle is typically a milder climate than we are is because of its proximity to the ocean. And so it does get hot there and it does get cold there, but it doesn't have near the extremes that we have here in the inland Northwest, where we don't have the water to mitigate our climate. But you even see this in little microclimates around here. For example, the areas near Lake Chelan, where they have a lot of vineyards now, and Lake Chelan is its own viticultural area. Like it's basically it's its own grape growing region that's recognized now because of its particular soils and climate. And the lake is big enough that it actually, when you're near the lake, it modifies the climate so that you can grow different varieties of grapes there than you can in other places, even just near there. How about another one? It's a good solvent.
Oh, yeah. There's one.
So that allows the chemistry, which we'll learn more about shortly. The chemistry of life happens in water solutions, right? Your body is 70-ish% water. If you were to, knock yourself out and dehydrate yourself, I don't recommend that, but you'd lose about 70% of your mass by the time you got completely dried out. And, yeah, so that is about it. I mean, there's a lot more properties of water that you could list there. You could list surface tension, you could list several other properties of water. The important part of this is that you list them and you also discuss why that property is essential for life. So you're looking at probably 15 points for this question. Probably only 5 points for this question. Probably like 1 or 2 points for each definition. Maybe 3 points, maybe only 2 points for being able to write CHNOPS.
You should make it.
Maybe 4 points for the differences between ionic and covalent bonding, and maybe 4 points, so like a good maybe 20% or so of your test, maybe even 30% of your quiz tomorrow is properties of water that make life on Earth possible. Aaliyah?
For the elements one, do you want the actual names, or can we just write the like all?
You can write the symbols.
Okay.
So.